Okay, hi everyone. Thank you for joining me. Maya, can you hear my voice?
Yes.
And what do you see on my screen? Do you see the assignment?
Yes.
Okay, let's start. Um, MCQ, is there anything you want me to discuss from questions 1 to 5?
Hello, Miss Lina. Can we do
Yes.
question 3?
3.
Yeah.
So hydrogen bonding would be definitely this OH group makes it hydrogen can form hydrogen bonding, but this O is not directly bonded to any hydrogen, so it cannot hydrogen bond with any with another molecule like this, right? So only 2. Anything else?
No.
CO2 is polar because O is more electronegative than C, but due to the linear and symmetrical structure, that's why the dipoles cancel each other, so the overall molecule is nonpolar.
Can you explain question 9?
Question 9, yeah. Question 5, is everyone okay? Here I am showing like the rough structure. Okay. So if you feel like I need to go back, just let me know. Question 9, resonance effect. So here, so the answer is SO2 because SO2, all right, SO2 can form something like this, or it can form something like this, right? So if, let's say, we have this kind of structure, now the lone pair on O can move here, and then this double bond one of them will fall out like that, and it forms the resonance structure. So this is the most likely molecule to have resonance structure, okay? Whereas HCOOH, if it resonates, it's slightly possible because it does have the lone pair on the O and also the double bond, right? So if, let's say, this double bond, the pi bond goes to O, like in this structure, then that means the C now becomes positive, and this lone pair on the O will go and make a double bond with the C to make C neutral, all right? But it will result in a positive oxygen. So oxygen is an electronegative atom, so it's not likely to have a positive partial charge. That's why this resonance is less possible than SO2. Okay, let me just show you why this O is now positive. So O should have 1, 2, 3, 4, 5, 6 valence electrons. So if it makes a double bond here, these 2 electrons belong to O. This 1 electron belong to O, right? And then 2 more from lone pairs. So overall, we can say that O has 5 valence electron, not including the bonded pair, all right? So from O itself, it's only 5 valence electrons, whereas O should have 6 valence electrons. So O with 5 valence electrons, that means this O is positively charged. And this O is now negatively charged because, wait, yeah, this O is negatively charged because there is one electron that comes from O in this bonding pair. So we're not counting the electron from carbon. So only the dot, 1, 2, 3, 4, 5, 6, 7, right? O should have 6 valence electrons if it's a neutral atom, but having 7 valence electrons, that means this O is negatively charged. Is there any other question from 9?
Miss, what's resonance effect again? Like, is it delocalizing of electrons?
Yes, it is delocalizing of electron, particularly if you have a very large structure like graphite, you have different hexagons like that together, right? So yeah, so it goes on and on and on. So the lone pair, no, actually, you can draw this like this structure, right? So each of the double bond here, the pi bond, can delocalize like that, like that, like that, and so on and so on. That's how the whole structure can conduct electricity, right? If you are imagining the orbitals, that would be the p orbital on each carbon, yeah, they will be able to exchange or sort of like exchange electrons. So the electrons will go on and on in the p orbitals of the carbons. Yeah, so the position of the double bond and lone pair can change. That's called resonance effect.
So when they change a lot, there's high resonance effect, right?
Correct. Yeah. Okay. Number 10 is just looking for something with hydrogen bonding and the smallest nonpolar portion. Okay. Number 11. Any problem? Number 11? Okay, now 12 to 15.
Can you explain 12?
Yes. The smallest bond angle, that means, okay. What was your answer? Who asked the question? Ashley? What was your answer?
A.
A. Yeah, A is O with 2 lone pairs, so it's actually 4 electron domains. That means the angle here is just less than 109.5, right? But xenon F4, xenon has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, and 4 of them form bonding with fluorine. So that makes a total of 1, 2, 3, 4, 5, 6. 6 electron domains. Now, if you have 6 electron domains, you start off with that's wrong. You start off with octahedral like that, and the lone pairs will be 180-degree from each other. So it can be up and down like this, or front to back like that, or the other way like that, right? So the molecular geometry itself is just square planar, which is 90 degree. The lone pairs need to be 180 degree from each other because they want to be as far away as possible from each other. Okay, and square planar geometry again. So I always draw it out. Iodine has 7 valence electrons, but you have this minus sign. So let's draw 8 valence electrons for iodine because we need to put that that one negative charge somewhere, and it's bonded to 4 fluorine. So 1, 2, 3, 4. Again, for this structure, iodine has 6 electron domains, so it's very similar to xenon. Whereas SF4 is seesaw. Yeah, so
How do you know when one is tetrahedral and one is square planar?
Square planar is only when you have 6 electron domains. Tetrahedral is 4 electron domains. Like silicon. Silicon has 1, 2, 3, 4, and then all of them bond with F, like in A, 1, 2, 3, 4. So still 4 electron domains that will give tetrahedral. Any question? Okay. 14. Solvated means dissolve. Or so an ion, when an ion is solvated, it will be something like this. Water particles surrounding the ion in all direction. This is called solvation. 15. So A is wrong because ionic bond and covalent bonds are both strong, but when wait. But when you melt something in ionic bond, you overcome the intermolecular force, which is the ionic bond itself. But in covalent bond, when you melt something of simple structure, you actually overcome the intermolecular force, not the covalent bond. That's why A is wrong. Okay. Any question? 15? No? Okay. So I'll just show you this. I think most of you got this. Can you ask me if you want me to draw from scratch? All right. Question 2. So you need to explain your answer here, right? So for CO, it's just one bond. So I need to use electronegativity difference to see if it's polar or non-polar bond. So that's why I have the electronegativity difference. For BCl3, I need to consider the geometry as well because I know that Cl is a more electronegative element. So the dipoles go like that towards the Cl, but because of the symmetry of the geometry, which is trigonal planar, and you have to mention the name of the geometry, then the dipoles cancel each other. Okay, next is Cl is it more? I think nitrogen is more electronegative than Cl. So the net dipole moment is pointing towards nitrogen, and that's why it's polar, right? Because the dipoles do not cancel each other. Now, a lot of you do not know how to draw CH3NH2. So this is the structure, and it is polar because N is the more electronegative atom. So the dipole moment is pointing to N more than anywhere else. So this N will be your delta minus, and on this side, it'll be delta plus. Okay, and each of the hydrogen here is also delta plus. So it's not symmetrical. The geometry on N is trigonal pyramidal. And yeah, net dipole moment is pointing to N. Moreover, there is lone pair of electron on N. So N has greater electron density than anywhere else in the molecule. Okay, and H2S looks like that. Okay. B, ethanol and methoxymethane. Yeah. So explain the differences. That means you need to explain the miscibility in water. Miscibility means almost like dissolving. You can't distinguish anymore the layers, okay? Because everything mix, everything dissolve in one another. So this miscibility depends on their ability to form hydrogen bonding with water. So please write down with water. This is to explain miscibility. Ethanol is miscible in water because it forms hydrogen bonding with water. Whereas methoxymethane does not form hydrogen bonding, but it has PDPD, which is weaker in the molecular force compared to hydrogen bonding. And then you can talk about the boiling point. Thus, weak van der Waals requires less energy to overcome. So that means lower boiling point. Question?
Miss Lena, why
Yeah.
doesn't hydrogen form, like why doesn't hydrogen bond form in deoxymethane even though there's lone pair in the
Yes. So there is lone pair on the O, you're saying. Why can't it form hydrogen bonding? Because there is no... Okay, you are correct to say that CH3, CH3, and water like that can hydrogen bond, but this is very, very limited because the methoxymethane itself does not have hydrogen connected to the oxygen. But you are right. If let's say you explain that methoxymethane only forms limited hydrogen bonding with water, that's why it has limited solubility in water or only very slightly soluble in water, then it could be marked correct. Yeah. Yeah, possible. So this is about the miscibility, right? But when you're talking about a boiling point, definitely between methoxymethane and another methoxymethane molecule, there is only PD-PD. Yeah. Any other question? Okay. So check here and tell me if you have any question. This 107 degree, you can also say less than 109.5 because it's not exactly ammonia. Oh yeah, for this, some of you gave a good answer that you say, oh, this is sigma, right? And then this one is 1 pi bond, and then the rest is sigma. Yeah, you can also draw it like that. Pi, sigma. Okay, next. For this, you need to say that because they're all nonpolar, so the strongest van der Waals will be ID-ID. And ID-ID depends on the number of electrons, therefore the electron cloud size, all right? And S8 has the most number of atoms, therefore the largest electron cloud. Larger electron clouds are more polarizable, so stronger ID-ID. Ethanoic acid is soluble, but not octanoic acid. You have to say that both acids have OH group, so they can hydrogen bond with water, but this portion of nonpolar portion of octanoic acid is larger. That's why it becomes less soluble. Okay, but you need to say that both can hydrogen bond with water because of the OH group. Okay. Section C, any question for question 1? No? All right. Question 2 is just nitrogen is from period 2. So quantum shell 2 only has S and P subshells. It doesn't have D subshell. So maximum occupies 8 electrons. But P is from period 3 and quantum shell 3 has S, P, and D. So it can have extended octet. Write down chemical equation. Guys, you're not in IGCSE anymore. They will not say write down and balance. They won't say that. So if you write me unbalanced reaction equation is 0. Okay. You don't need to be told. Question?
Miss,
Yeah.
can I have time to write this down? Give me a second.
Yes.
All right, thank you. Okay, thank you.
Okay. Question 3. Some of you, I think, confuse P4 and confuse CO and P4. Yes, it's true that CO is polar, so it has PD-PD, and P4 is nonpolar. Actually, P4 looks like this. 1, 2, 3, 4. Ugh. I'm trying to make it look good. Maybe not good. Okay, it looks something like this, like a pyramid, right? That's P4. It is non-polar, so ID, but due to the size of the electron cloud is so big because 4 phosphorus, it becomes very polarizable. So it's quite a strong ID. And at the end, this ID is stronger than the PD and carbon monoxide. Yeah. Okay. So that's all. Done. B. Phosphorus P4 is nonpolar ID, so it dissolves in nonpolar organic solvent like hexane, but not in polar solvent like water. In the exam, they want you to write that that hexane is nonpolar, water is polar, and P4 is nonpolar, right? Don't just assume, oh, the examiner knows already water is polar, right? And don't assume that. You have to write down. Okay, so look, a lot of you say hexane because hexane will dissolve phosphorus, which is true. But the point of putting phosphorus in a liquid is to store it under a liquid so that it doesn't spontaneously react with in air, right? So it's not to dissolve it, but it's to protect it from air. If you have phosphorus, which is a solid here, is condensed to a solid, and then you dissolve it in hexane, you don't have your solid anymore, right? Then you have to do separation. You have to evaporate the hexane. But that's not why you want to put it in a liquid. You want it so that it does not react in air. So you have to put it in water. It doesn't react with water, and it also doesn't dissolve in water. So you can take it out anytime as solid. Okay? Okay, that's it for assignment 4. I have practice question I'm going to send you in line, but I'm gonna log out and you should log out and then log back in because the thing is going to turn off in 5 minutes. Okay? See you soon.